October 25th. Just after 200 hours, UTC solar wind telemetry from the Parker Solar Probe registered a narrow band fluctuation, a repeating energy pattern precisely synchronized with the trajectory of 3i Atlas. The signal wasn't strong, but it was structured. It carried intervals, pauses, returns, not noise, rhythm. For weeks, the object has drawn global attention for its strange behavior. A primary jet that points directly toward the Sun, nickel-only outgassing that defies every known comet model, and stable flares that ignite at almost mechanical regularity. Now, the data feed adds something new: timing, a rhythm inside the radiation itself. Inside NASA, the tone has shifted from curiosity to containment. Official channels remain silent, while ground-based observatories are quietly comparing the modulation frequency to past magnetic oscillations of the Sun. The alignment is exact, and if that's not coincidence, then something, or someone, is responding. We are days away from October 29th, when 3i Atlas slips behind the Sun in what analysts call a blind window. No telescope will see it. No probe will measure it directly. For nearly 4 weeks, the object will vanish. But before that happens, the pattern keeps repeating, as if it wants to be noticed. This is where the story begins. The first confirmed pattern in the data, and the first sign that 3i Atlas may not be silent after all. At first, it looked like static. On October 23rd, a small anomaly appeared in the Parker Solar Probe's particle flux stream, a barely perceptible rise and fall in charged particle density, spaced at regular intervals of roughly 11 minutes and 14 seconds. Analysts flagged it as background interference, possibly telemetry compression noise, but the same signature appeared in the backup feed, and again 12 hours later. When the probe shifted position and crossed a different sector of the solar wind, the pattern followed. Not the particles, the rhythm. The fluctuation remained phase-locked to a position just ahead of the heliocentric coordinates of 3i Atlas. That's when the comparison began. Data scientists mapped the frequency against the comet's rotational models, drawn from earlier Hubble and ground-based observations. None of the models matched. The periodicity wasn't rotational, thermal, or magnetic. It wasn't solar background modulation either. The 1114 interval had no precedent in heliophysics. Then, something stranger. On October 24th, the interval shortened, slightly, by less than 0.4%. The phase shift corresponded exactly to a small deceleration in 3i Atlas's measured velocity. The object slowed by less than 0.01%, yet the modulation adapted with mathematical precision. No natural plasma interaction does that. Even more concerning was the spectral content. Using the Heliospheric Observatory's secondary magnetometer feed, analysts isolated a faint electromagnetic echo embedded in the particle stream. It was broadband, but with a narrow dip around 8.3 kHz, almost like an engineered filter notch. For a moment, the data team considered instrument error, but the same pattern appeared in the solar orbiter's readings, separated by nearly 0.7 astronomical units. 2 independent probes, 2 identical patterns. No shared hardware, no shared code. The correlation was real. By the end of the day, the internal summary report used a single phrase: non-random periodic fluctuation correlated with interstellar object 3i Atlas. The news didn't reach the public immediately. It passed quietly through private telemetry channels between NASA, ESA, and a few independent research centres. But among those who saw the numbers, the reaction was unease, not fear, just a silence that meant no one knew what they were looking at. Because in all the data archives of cometary science, nothing like this exists. Comets don't pulse, jets don't regulate themselves, and the solar wind doesn't sing in 11-minute intervals. To some, this was a calibration ghost, a coincidence buried in the noise. But to others, it was a signature. The first measurable sign that something inside 3i Atlas was active, rhythmic, and aware of its environment. The immediate question became what could generate such a pattern? Natural resonance, rotational venting, or something deliberately structured to mimic both? Here's where it gets even more complex. The Arecibo dataset from 2019, long before 3i Atlas was even discovered, shows a background hum at the same frequency when aligned with the inbound trajectory path. In hindsight, it wasn't random interference, it was an early echo, faint but consistent, moving through interstellar space. Now that same rhythm echoes across the solar system, synchronized to an object made of nickel, venting metallic compounds that don't belong in a comet's breath. And this pattern, this quiet heartbeat in the solar wind, might be the first clue to its origin. But before we can understand the signal, we have to understand its source. Because what's pulsing might not be gas, it might be metal. Spectroscopic analysis from both the Very Large Telescope in Chile and the IRTF array in Hawaii confirmed it. 3I Atlas isn't venting the usual mix of water, carbon dioxide and silicates seen in ordinary comets. Instead, its emissions are dominated by nickel, pure nickel, accompanied by trace levels of a rare compound, nickel tetracarbonyl. That discovery alone is enough to unsettle any planetary scientist. Nickel tetracarbonyl doesn't form easily in nature. It's volatile, toxic, and usually produced industrially in refineries and metal purification systems. For it to appear in measurable quantities in space, under near-vacuum conditions, defies what we understand about spontaneous geochemical synthesis. When the first spectra came in, some dismissed the readings as contamination from instrument residue, but reruns from independent telescopes showed identical peaks. Even more striking, the compound's relative abundance was changing over time. The Ni:/Fe ratio was increasing. Day by day, the iron signature weakened while nickel lines strengthened, as if the object was refining itself in real time. In standard cometary evolution, ratios broaden as volatiles evaporate unevenly. You get noise, not order. But 3I Atlas is narrowing, self-stabilizing, its spectral bands into uniform lines, like a controlled process. To understand how unusual that is, you have to picture what outgassing usually looks like. A comet spins, sunlight heats its surface, frozen gases vaporize and jet outward chaotically. Each flare alters the spin, exposes new areas, and changes the spectrum. What astronomers see is turbulence, random, spiking, and messy. 3I Atlas is the opposite. Its flares are smooth, periodic, and compositionally consistent. The nickel signature repeats with machine-like precision, within measurement error margins as low as 0.2%. That level of consistency is not natural, it's regulated. Some researchers have tried to frame this as an exotic mineral phenomenon. Perhaps the object's crust is unusually metallic, the product of supernova-forged grains condensed in an oxygen-poor nebula. Others propose that cosmic rays could have reduced iron oxides over millions of years, leaving a nickel-rich residue. But neither scenario explains the presence of nickel tetracarbonyl. That molecule breaks down instantly under radiation. It shouldn't survive more than seconds in sunlight, yet in 3I Atlas, it persists for hours. The only way to sustain such a compound is through constant replenishment, as if a hidden reservoir keeps producing it and venting it outward through directed jets. That's when analysts began looking deeper into the emission geometry. Every spectral line came from the same vector, the same part of the object, always facing the sun, the so-called primary jet, the one that refuses to behave like any other cometary vent ever recorded. It emits heat, light, and metallic gas, all directed toward the sun, not away from it. That's like a rocket firing into the wind, and yet the object remains stable. No spin correction, no disintegration. It's as if it compensates. If you chart the data over time, the nickel intensity correlates almost perfectly with flare amplitude. When the light curve spikes, nickel concentration rises. When it dims, the ratio drops. The flare cycle and chemical release are synchronized, implying an internal regulation mechanism. There's one more detail that researchers whisper about but haven't officially published: the emission temperature. Thermal modeling suggests the vented gas is not sublimating from ice. It's being released at a controlled temperature, hovering near 480 degrees Celsius. That's the optimal range for industrial nickel carbonyl decomposition. The same range used in terrestrial refining furnaces. Coincidence, perhaps. But in physics, coincidences that repeat demand scrutiny. Some call it the Atlas refinery hypothesis, the idea that 3I Atlas is not simply losing material, it's processing it. The surface heats, reacts, vents, cools, and repeats in cycles that mirror engineered systems. NASA hasn't endorsed the claim, ESA won't comment. But behind the scenes, internal memos describe the nickel emissions as chemically inconsistent with known cometary activity. Which raises the next question: if the nickel outgassing is deliberate, what's powering it? And why is the jet facing the sun? because the next anomaly makes even less sense. The engine, if that's what it is pointing the wrong way. When sunlight strikes an icy nucleus, sublimation always pushes gas outward, forming a tail that trails behind or slightly sideways depending on the solar wind angle. That rule has no exceptions in recorded astrophysics. Yet telescopic tracking from the Mauna Kea and La Silla observatories shows 3I Atlas maintaining a jet aimed directly toward the Sun, a plume of metallic vapour seemingly defying both radiation pressure and logic. The geometry alone is staggering. The jet projects roughly 11,000 kilometres long, bright in the near-infrared but faint in visible light, its orientation unwavering for weeks. Even as the object rotates, the jet compensates, pivoting to keep its axis fixed on the solar disk. To accomplish that naturally, the nucleus would have to rotate precisely in sync with its orbital position, an almost impossible balance given the torque such a jet would induce. At first, analysts assumed we were seeing an illusion, perhaps a secondary jet on the far side creating a false alignment. But solar wind backscatter data from the Parker probe disproved it. The magnetic field lines around the object bend asymmetrically away from the Sun, as if a steady thrust were pressing against the plasma flow. The plume truly points sunward. This presented a physical paradox. The sunlight that should push material outward appears instead to be pulling it in. Something near the nucleus seems to absorb and then re-emit solar energy in a controlled direction, the very definition of active regulation. A team at the Arecibo successor array ran simulations. If the jet was simply a vent of volatile metals, the object would spin out of control in under 6 hours. It doesn't. Its angular momentum has barely changed in 10 days. The only way to stay stable is to counter-thrust. That means multiple vents firing in perfect sequence, or a mechanism compensating internally. One researcher described it bluntly. It behaves like a craft maintaining attitude lock. NASA's public statement avoided the word jet altogether, calling it a localized albedo enhancement. Yet infrared readings show kinetic motion, gas moving at nearly 3 kilometers per second, producing measurable recoil. The object is reacting to that recoil deliberately, not chaotically. When scientists mapped the flare cadence against the Sun's activity, another layer emerged. Each major burst aligned with small fluctuations in solar flux, as if 3I Atlas anticipated or responded to the Sun's microflares. The synchronization lag was under 40 seconds. No passive body could react that quickly across 0.8 astronomical units of space without an internal feedback system. That's where the theories split. The conservative camp argues for a complex but natural feedback loop, metallic grains conducting heat unevenly, creating thermal stress cycles that mimic control. A rare, yes, but conceivable phenomenon. The other camp, quieter and mostly off-record, notes that nickel tetracarbonyl decomposes when exposed to ultraviolet light, releasing pure nickel vapor. If that vapor is channeled magnetically, it could produce microthrust. In other words, 3I Atlas might be using sunlight itself as fuel, converting photonic energy into directed outgassing. Not a solar sail, a solar engine. It would explain why the jet always points toward the light. The reaction isn't resisting the Sun, it's feeding on it. Still, the implications are enormous. If true, this would mean the object can regulate energy intake, converting solar heat into mechanical output, an ability no comet or asteroid has ever displayed. Observers at ESA's solar orbiter attempted to confirm by measuring the jet's spectral polarization. The data came back inconclusive, but one detail stood out. The polarization axis rotated slightly, by 1.7 degrees every time the flare amplitude changed. It's the optical signature of a controlled magnetic field, pulsing in rhythm. So the jet may not just be thermal, it may be electromagnetic. That's when the phrase regulated flares entered the internal notes. Because what looked like venting now resembled timing, deliberate measured bursts repeating in near-perfect cycles. And if that timing holds, it means the jet isn't the anomaly's byproduct, it's the message. 3 independent observatories, one in Hawaii, one in Spain and one in Chile, have been monitoring the object's flare activity continuously since mid-October. Each reports the same finding. The intensity spikes occur at near exact intervals, maintaining a variance of less than 0.3%. In space, where temperature, spin, and radiation pressure constantly fluctuate, Such precision borders on impossible. Natural jets pulse chaotically as sunlight heats uneven patches of volatile material. They surge, dim, and then erupt again, never on schedule. But 3i Atlas repeats in rhythm, 11 minutes, 14 seconds, again and again, like a heartbeat embedded in the void. When analysts overlaid the flare-like curve with the solar wind density recorded by the Parker probe, a stunning correlation appeared. Every time the solar wind dipped, the flare brightened, compensating for lost radiation pressure. When the wind strengthened, the flare dimmed. It was as if the object were maintaining balance, regulating energy output to counter external forces. This pattern isn't guesswork. Over 600 cycles have now been logged, all within the same amplitude envelope. No comet has ever displayed thermal regulation like this. None. The phenomenon grew stranger when spectroscopy was applied. During each bright phase, the nickel emission line surged sharply before fading, not gradually, but in a clean rise and drop curve. That's a controlled process, not thermal lag. It's like a pulse of power being switched on and off with precision timing. The internal modelling group at NASA's Goddard Center tried to simulate the effect using natural parameters: rotation, vent geometry, sunlight angle, material composition. No combination could reproduce both the interval and the amplitude stability. The only models that fit required an active feedback loop, sensors and regulators adjusting flow in real time. Some within the team began referring to the cycles as Atlas beacons. The term didn't survive peer review, but the idea did. If the pattern holds consistent across changing heliocentric distance, it's not just venting, it's signalling. ESA's solar orbiter corroborated the existence of short ultraviolet flashes, preceding each flare by roughly 7.9 seconds. The lead time is consistent across all observations, suggesting the object emits a pre-pulse before the main burst, possibly a priming event, like a capacitor discharge. If it were simply gas venting, no such anticipation would exist, yet 3i Atlas appears to prepare before each flare, storing energy, then releasing it with perfect symmetry. Meanwhile, the A Coruña research group, the one promoting a natural interstellar origin, insists the pattern might arise from rotational aliasing. Their argument: if the nucleus spins at a multiple of the observed period, sunlight could trigger jets sequentially, creating an illusion of regular timing. But their own simulations contradict that idea. To sustain the illusion, the rotation would have to remain locked with solar radiation at a fixed rate for weeks, without precession. Even slight drift would desynchronize the pattern. It hasn't. Observers at Cerro Paranal tested another theory, that the periodicity is magnetic, not mechanical, an interaction between the nickel-rich plasma and the sun's fluctuating field. They expected randomness. Instead, they found coherence. The flares occur at magnetic minima, not peaks, exactly when the solar field offers the least interference. In other words, 3i Atlas seems to choose its timing. The internal logs at ESA now use careful phrasing: quasi-regulated flare activity. The term allows scientific ambiguity while acknowledging the underlying order. But within private circles, some physicists admit what others won't say aloud. The pattern is deliberate. There's also the question of modulation depth. During the strongest cycle on October 24th, the flare brightened by a factor of 2.6, then returned to baseline within 3 seconds. That rapid attenuation indicates internal control. Thermal diffusion alone couldn't cool the surface that quickly. It's as if an internal shutter closed, cutting the reaction instantly. Add to that the symmetrical intervals, the pre-pulses, and the chemical regularity, and you have a phenomenon that mirrors engineered systems more than natural ones. Still, science demands restraint. Every alternative, even unlikely ones, must be tested before implying intelligence. But the data itself leaves a riddle. If the object is alive, what purpose do the flares serve? Communication, propulsion, thermal control? Each possibility points to a deeper mystery, one that only its trajectory can answer. Because when the timing, chemistry, and geometry all converge, one pattern remains: precision. And precision in nature usually means intention. The next question NASA faced was whether that precision extends to its path through the solar system. Because if it does, 3i Atlas isn't drifting randomly at all. It's navigating. Since its discovery, astronomers have noted that 3i Atlas moves through the solar system with an almost uncanny grace. Its trajectory isn't erratic like a comet's, it's exact, deliberate, and smooth. The inclination, just under 0.6 degrees relative to the ecliptic, places it practically in the plane of the planets, an alignment so statistically rare that it raised eyebrows the moment it was calculated. Most interstellar visitors arrive at random angles, plunging through the system like cosmic debris. Oumuamua came in steep, hyperbolic, and left just as unpredictably. Borisov was wild and fast, but 3A Atlas is gliding through the solar system's mid-plane like it belongs here, a low-inclination approach that mirrors the orbits of engineered probes rather than comets. It's not just the inclination, its eccentricity and velocity vector are unusually stable. Over the last 60 days, as gravitational influences from Mars, Earth and Venus shifted subtly, 3I Atlas's path should have wobbled slightly. That's orbital mechanics 101. Yet astrometric tracking from the Las Campanas Observatory shows zero measurable drift. Every projection holds true to within 0.002 degrees. That's extraordinary and improbable. NASA's JPL team modelled the orbit under multiple perturbations: gravitational, thermal and outgassing recoil. The simulation predicted slight but cumulative deviation. It didn't happen. The real object stayed locked to its expected coordinates, as if it corrected itself mid-flight. There's no public acknowledgement of this, but leaked correspondence from the European Space Operations Centre references a stabilisation anomaly. In one message, a flight dynamics engineer writes, "The object appears to maintain mean motion resonance stability, inconsistent with natural outgassing torque." In plain language, something is holding it steady. Some scientists suggest that this could be the result of symmetrical outgassing on multiple axes. If the jets balance perfectly, the torque cancels out. The problem is that perfect balance doesn't exist in nature. Material surfaces aren't uniform, sunlight angles shift, and vent pressure fluctuates. Even if balanced momentarily, it would drift over time. 3I Atlas doesn't. Its orbit has another oddity: timing synchronization. Each perihelion adjustment corresponds exactly with minor solar oscillations, as if the object anticipates variations in the Sun's gravitational influence. When the Sun's magnetic field tilts, 3I Atlas adjusts its periapsis argument fractionally, keeping its trajectory centered in the same orbital plane. That level of responsiveness implies a feedback mechanism, something tracking the environment and compensating, not by coincidence, but by design. To visualize how unnatural this is, imagine tossing a pebble into a turbulent river and watching it hold course against every current. That's what 3I Atlas is doing in space, staying perfectly online while the gravitational field around it shifts. Even its velocity profile is precise. As of October 25th, it's moving at about 31.8 km per second, right on the predicted curve. Yet the Doppler spread is suspiciously narrow, too clean. Most cometary Doppler readings show fuzziness due to venting, spin and particle drift. Here, the line is sharp, coherent, like a solid body under control, not a cloud of debris. That coherence may be why it's so hard to classify. 3. I Atlas behaves less like a tumbling rock and more like an object under gentle thrust correction. In fact, when mission analysts ran the data through propulsion models, the observed motion could be explained by a microthrust of roughly 0.0008 newtons, almost nothing, yet exactly enough to nullify natural drift. If that microthrust comes from outgassing, it's the most consistent outgassing ever recorded. If it's something else, an internal mechanism regulating momentum, then we're no longer talking about a comet. The Spanish team at A Coruña dismisses this, insisting the motion fits a natural interstellar body with coincidental geometry. Their model traces the object back to the galactic thin disk, a dense region of star formation. According to them, 3I Atlas's path through our system is a statistical fluke. But flukes don't repeat, and the same researchers admit their Monte Carlo simulations only reproduce the observed parameters in 1 out of 8 million runs. Statistically possible, yes. Scientifically satisfying, no. The deeper issue is what happens next. In 4 days, on October 29th, the object begins to move behind the Sun. When it does, direct observation will be impossible until late November. If any course correction occurs during that blackout, we won't see it, only the results when it re-emerges. That period, the blind window, could change everything. because if 3I Atlas exits the conjunction, even a fraction of a degree off course, it means it manoeuvred. For now, all we can measure is perfection, chemical precision, thermal rhythm, and orbital discipline that defies randomness. But behind that order is a question no one at NASA wants to phrase out loud. If it's not coincidence, who or what is guiding it? And why is one European model so certain that everything we're seeing can still be explained away? In late September, a small research team at the University of A Coruña in Spain published what they called the thin disk model, a simulation tracing 3I Atlas's origin to a population of interstellar objects drifting quietly through the galactic plane. According to their findings, this object isn't engineered, guided, or exceptional. It's natural. Statistically rare, but not impossible. The paper reconstructs 3I Atlas's incoming trajectory using reverse orbital integration, essentially rolling back the clock to see where it came from. Their result? An ejection from the galactic thin disk, roughly 42 million years ago, caused by gravitational scattering from a binary system. From there it drifted freely until crossing into the solar system earlier this year. Their central argument hinges on probability. Interstellar debris isn't uniform, it's clumped, directional, and dense along galactic planes. If Earth has already witnessed Oumuamua and Borisov, the odds of a third object passing within a decade aren't impossible. 3I Atlas, they write, represents the natural continuation of a statistical series, not an anomaly demanding exotic explanation. It's a compelling narrative, calm, measured, rational, but it collapses under closer inspection. For one, the model assumes a neutral composition typical of oxygen-rich comets: silicates, carbon dioxide, water ice. Yet the actual spectra show none of that. The nickel dominance, the carbonyl traces, the absence of volatiles, none of it fits their parameters. When questioned, the authors responded that metallic enrichment could result from high-temperature processing near a young star, but that explanation contradicts the isotope ratios. 3I Atlas's isotopic signature doesn't match stellar reprocessing, it matches refined metal. The A Coruña team also dismissed the sun-pointing jet as a thermal misinterpretation, suggesting that observational bias made it appear inverted. Yet they ignored corroborating plasma data from Parker and Solar Orbiter, two independent instruments confirming directional thrust toward the Sun. Their model simply erases the anomaly. More concerning is the way their simulation treats stability. The thin disk model predicts minor precession, a gradual drift in trajectory over time. But the real 3I Atlas has shown no such drift. It's holding steady, almost perfectly. The paper attributes this to measurement uncertainties, a convenient way to sidestep the evidence. Still, the model served an important function. It gave agencies, NASA, ESA and their public relations arms, a narrative to point to, a natural explanation, a way to quiet speculation, and speculation needed quieting. By early October, leaked notes from an internal NASA teleconference revealed that at least 3 independent analysts had flagged active stabilization patterns in 3I Atlas's motion. The A Coruña model appeared 2 days later, accompanied by a joint NASA-ESA statement citing it as the most comprehensive current assessment. The timing wasn't lost on anyone. Privately, several astrophysicists criticized the paper's selective use of data. One of them, speaking under anonymity to Nature News, called it a placeholder for reassurance. The phrase caught on. To many, the A Coruña model feels less like science and more like containment, a neat box for an object that refuses to fit inside one. To their credit, the authors admit one unresolved issue, the evolving nickel-to-iron ratio. Their explanation: variable surface exposure. In other words, as the object rotates, different metallic layers vent at different rates. But the rotation speed measured by the Hubble follow-up team is too slow for that. The changes occur faster than any plausible rotational exposure could cause. So the A Coruña model, while elegant, fails the test of self-consistency. It fits only if you remove the anomalies, the same anomalies everyone's observing. That's why the debate now runs deeper than science. It's become a matter of trust. Trust in data, trust in institutions, trust in what we're told. Because while the public reads one thing, the observatories see another, and what they see is increasingly difficult to explain. Even within NASA, quiet divisions are forming. Some want to confront the data head-on, no matter how unsettling. Others argue for restraint, to avoid public panic before the conjunction blackout. Meanwhile, another mystery has begun to surface. Several expected data releases, images, spectra, raw photometry, have not appeared. They exist, but they're missing from the public repositories. That silence may be procedural, or it may not. Because when an anomaly threatens to rewrite physics, information control becomes part of the investigation, and right now that control is tightening. Over the past 2 weeks, a strange pattern has emerged. Not in the sky, but in the flow of information. Normally, when an interstellar object nears perihelion, data pours out from every instrument in the solar monitoring network. Raw photometry from the Mars Reconnaissance Orbiter, spectrographic readouts from JWST, ultraviolet snapshots from SOHO. But as of October 25th, none of the usual updates have appeared. The Mars Reconnaissance Orbiter, which reportedly captured several close-range images during its last observational pass earlier this month, has released nothing. Not even a metadata entry confirming the images exist. Researchers who track NASA's open access pipeline noticed that the catalogue IDs jump abruptly. Entire sequences missing between October 13th and 18th, precisely when 3i Atlas passed within the orbiter's visual range. When questioned, a NASA spokesperson replied that the data did not meet calibration standards and were under internal review. Yet internal review normally takes hours, not weeks, and the orbital geometry suggests those images would have been the clearest yet, potentially resolving surface details smaller than 100 meters. At the same time, the James Webb Space Telescope's public observation schedule quietly removed its planned 3i Atlas spectra. Initially listed for October 22nd under program ID 5553, the entry vanished without comment. An archived version of the schedule still shows the target name, later replaced with TBD, Solar System Object. The timing is not subtle. Within the astrophysics community, whispers began to circulate about a data embargo. The official justification is solar interference. The object's proximity to the Sun creates glare that complicates calibration. But observers point out that JWST has successfully gathered spectra closer to the Sun before, under worse conditions, so the blackout looks less like caution and more like containment. Meanwhile, the ESA's Solar Orbiter team released a brief technical note acknowledging anomalous telemetry inconsistencies near 3i Atlas's coordinate field. But no charts, no images, no error logs, just a paragraph. It's not the first time agencies have gone quiet. In 2017, during the Umama controversy, a similar silence followed early radar returns. But this feels different. The suppression isn't reactive, it's preemptive, as if they expected anomalies before they appeared. A leak from within NASA's Planetary Science Division, verified by 2 independent journalists, suggests a more complex reason. The internal memo reportedly cites spectral irregularities incompatible with silicate or ice-based models. The memo goes on, further dissemination of unvalidated data may risk speculative interpretations inconsistent with current policy. Speculative interpretations. That's the bureaucratic euphemism for public panic. It's not just missing data. Even communication frequency between agencies has slowed. Normally, cross-mission coordination logs are published weekly. This time, they're late by 11 days. Amateur astronomers trying to correlate their observations with official ephemerides report discrepancies of several arcseconds, meaning even the official position files may no longer match the real object. In an age where every telescope on Earth can live stream the heavens, silence stands out louder than noise. The blackout has become its own signal. The scientific community is split. Some defend the agencies, arguing that the Sun's glare near conjunction justifies caution. Others see a familiar pattern, the slow tightening of information when an anomaly crosses the line from unexplained to uncomfortable. Whatever the reason, the result is the same. No new imagery, no spectra, no public confirmation of what the observatories already know, yet fragments continue to leak. A European engineer uploaded a cropped telemetry graph before deleting it minutes later. It showed a sharp thermal gradient, a cooling curve inconsistent with sublimation, almost like heat dissipation through structured layers. If authentic, it implies internal composition far more complex than porous ice. NASA never commented on the image, but they didn't deny it either. So here we are, the world's best instruments aimed at an interstellar object venting metallic compounds, emitting rhythmic flares, maintaining perfect orbital precision, and suddenly, all data stops. That silence may hide more than just uncertainty. It may conceal a discovery too disruptive to manage in real time. Because when scientists stop publishing, it usually means they're recalculating, or that what they've found doesn't fit any known model, and right now a new model is forming, one based not on light, but on heat. Because what little data we do have hints at something deeper, hotter, and more deliberate inside the object itself. When astronomers first analysed the thermal profile of 3I Atlas, they expected the usual pattern of a sunlit interstellar object. A steep gradient on the illuminated face, a cold shadow region, and a predictable sublimation curve corresponding to distance from the Sun. Instead, what they found was a uniform temperature field, a surface that seemed to self-regulate, holding a steady range of 470 to 490 degrees Celsius across its observable hemisphere. That number immediately raised questions. Ordinary comets, even metallic ones, rarely exceed 300 degrees Celsius before losing volatiles and fragmenting. At 490 degrees Celsius, most ices would have long since vaporized, leaving an inert, cooling core. Yet 3I Atlas is not cooling. Its heat profile remains almost perfectly constant, as if governed by a thermostat. The readings come from multiple instruments. The most revealing was a composite analysis from the Solar Orbiter's Extreme Ultraviolet Imager and a near-simultaneous infrared sweep by the Mauna Kea Infrared Observatory. Both recorded identical blackbody peaks. The consistency between two independent instruments, one in orbit and one on Earth, eliminates the possibility of measurement error. At first, scientists proposed that a layer of metallic nickel might be redistributing heat evenly, acting as a thermal conductor, smoothing out hot and cold regions. It was a neat theory until they ran the math. For such conductivity to produce this stability, the layer would need to be several meters thick, which would make the object's density far higher than what its motion suggests. 3I Atlas's gravitational signature indicates a surprisingly light mass for its size, too light to be solid metal. So if it's not solid, how does it hold this temperature so precisely? That question led to one of the strangest analyses yet. Thermal models show a repeating rise and fall curve in the object's infrared output every 67 minutes, a subtle oscillation in heat that mirrors its flare rhythm, but at a different frequency. The heat pulse precedes each flare by about 4 cycles, almost like a build-up of internal energy before a surface discharge. It's not random, it's patterned. Dr. Eliana Mendez, a thermal physicist at the University of Arizona, called it an engineered rhythm of heat exchange. Her phrasing drew criticism for implying design, but the numbers back her observation. In her paper's appendix, later redacted from public access, she calculated a ratio of radiative efficiency that matches industrial heat transfer systems used in energy storage arrays. "You don't get that by accident," she wrote in an email now circulating privately among research groups. The most plausible natural hypothesis would be radioactive decay, internal heating from isotopes trapped during formation. Yet isotopic modelling shows no corresponding gamma emission or neutron flux. The spectrum is clean. Whatever heats 3I Atlas, it's not nuclear decay. That leaves only 2 broad possibilities: continuous chemical reaction or active regulation. Chemical self-heating might occur if reactive compounds interact within the object's porous interior, but for that to sustain such stability over weeks, the reaction would need constant replenishment of reactants. That would quickly exhaust available material. The nickel venting, instead of depleting, appears stable, even increasing slightly. This suggests replenishment or control, not depletion. So what kind of system could produce uniform, self-regulated heat across a rotating metallic body in open space? One idea circulating quietly among engineers, not astrophysicists, is inductive heating. If the object carries or generates a magnetic field, interacting with the sun's electromagnetic flux could induce eddy currents in its surface, producing consistent thermal output. Essentially, it could be drawing power from the solar environment itself, turning magnetic energy into heat. Evidence supporting this came indirectly from magnetometer data collected by the Solar Orbiter. The readings show a localized distortion, a kind of magnetic cavity, around 3I Atlas that moves with it through the solar wind. This bubble measures several thousand kilometers wide and attenuates the solar field inside it, almost like a Faraday shield. That kind of magnetic isolation would require internal conductivity and, more curiously, modulation. In natural terms, a metallic object can distort a field, yes, but not modulate it in rhythm with its own flare cycles. Yet that's exactly what's happening. The cavity expands and contracts on the same schedule as the light pulses, suggesting an internal system alternately storing and releasing energy. This dynamic could explain the thermal mystery. If 3I Atlas is actively converting magnetic flux into heat and then expelling excess energy through its sun-pointing jet, the entire system begins to make sense. The even temperature would reflect internal regulation, a balance between absorption and discharge. Of course, such a mechanism would be indistinguishable observationally from an engineered power cycle, which is why many scientists hesitate to publish this interpretation. The implications cross from astrophysics into technology. Another anomaly lies in the thermal inertia, the rate at which the surface responds to solar variation. During a brief solar wind spike on October 22nd, the sun's irradiance increased by 12%. Every nearby body, asteroids, probes, even Mercury's daylight side, registered corresponding temperature jumps. 3I Atlas did not. Its infrared emission curve flattened, almost as if it compensated for the surge by dissipating heat faster. That kind of compensation is unprecedented in any natural body. Thermal inertia can delay response, but it cannot invert it. Here, more sunlight led to less heat retention, a clear sign of active regulation. This raises a question few want to ask out loud. What if 3I Atlas's heat profile isn't a byproduct, but a signature of function? Some theoretical physicists have suggested that if an advanced probe used photothermal conversion, harnessing stellar heat for propulsion or communication, we would expect exactly this behavior. Temperature plateaus near 500 degrees Celsius, steady blackbody emission, and rhythmic thermal pulses synced with solar field shifts. It's speculative, yes, but the fit is uncanny. When journalists approached NASA for clarification, the official line was that thermal data remain under analysis. The tone of that statement contrasts sharply with the usual enthusiasm of scientific discovery. No numbers, no graphs, just a sentence. Behind the scenes, internal chatter at the Jet Propulsion Laboratory paints a different picture. According to leaked meeting notes from October 20th, engineers flagged anomalous retention of radiative equilibrium. Bureaucratic language for it staying too warm for too long. One attendee reportedly asked whether the pattern could indicate active thermal regulation. The note ends with a single line: topic deferred. What's becoming increasingly evident is that 3I Atlas behaves less like a body absorbing energy and more like a system managing it. The uniform heat, the pre-flare pulses, the magnetic cavity, they point to control, not chaos. It's as if the object has a metabolism, and that's where the conversation takes a darker turn. If the energy distribution is deliberate, then it's also coordinated. Multiple observatories report synchronized fluctuations in the infrared and ultraviolet bands, not randomly, but timed across hemispheres. In other words, one side of the object seems to know what the other side is doing. That implies internal communication, or at least internal coherence. Skeptics argue this could still be a natural resonant phenomenon, similar to thermal waves seen in metallic asteroids. But those are chaotic and decay quickly. 3I Atlas's thermal cycles remain strong after thousands of repetitions. Meanwhile, the public narrative remains stagnant. NASA's website mentions the object only in passing, while social media discussion grows daily. Some call it an engineered relic. Others believe it's a natural wanderer misunderstood by cautious scientists. Between those extremes lies the data, stubborn, precise, and unyielding. What few realize is that this thermal mystery may also tie into the earlier electromagnetic anomalies. The synchronized heat pulses coincide with low-frequency modulations detected by the Parker Solar Probe, faint radio signatures buried in the solar wind noise. The frequencies match the beat of the flare cycles, almost like an encoded carrier wave. If those emissions are natural, they'd mark a new kind of space plasma behavior. If they're not, if they carry structure, then 3I Atlas might be doing something no comet or asteroid has ever done: broadcasting. And if it's broadcasting, the question becomes, to whom? Because the thermal system seems to act as both engine and transmitter, converting absorbed solar energy into precise emissions. Whether that's a byproduct of unknown chemistry, or a deliberate signal no one knows yet. But the timing of the pattern, its mathematical precision, and its endurance under changing solar conditions has made one thing clear to those studying it closely. This object isn't passive, it's responsive, and the more it reacts, the more its heat tells a story, one not of decay but of function. A system built, not born. Whatever 3i Atlas is, it's not cooling down, it's regulating, on and preparing for something. Because each thermal pulse is growing slightly stronger, each flare slightly brighter, as if the cycle itself is ramping up. Something is building inside that metallic shell. And when it reaches the critical window, it might finally show us what it's been doing all along. In the first week of October, when data from the Parker Solar Probe and the Solar Orbiter began overlapping in their heliocentric coverage, analysts noticed something subtle but extraordinary. Buried deep within the solar wind telemetry, past the plasma turbulence, the noise, the field distortions, there was a repeating low-frequency modulation. It wasn't random static, it carried phase stability. The oscillation pulsed at 8.3 kHz, identical to the magnetic notch previously detected in the solar wind around 3i Atlas. At first, no one thought much of it. Electromagnetic anomalies are common near active solar regions. But when the oscillation's timing was compared to 3i Atlas's flare cycle, something clicked. The signals matched exactly. Every flare on the object's surface coincided with a brief reinforcement in the sun's magnetic background, as though the two were momentarily resonating. This discovery, now informally called the frequency lock, is what transformed the conversation from chemical oddity to physical impossibility. The solar magnetic field oscillates in countless frequencies, modulated by waves of charged particles from the sun's interior. For a distant object to match that oscillation so precisely, it would need to sense it, process it, and react to it in near real time. An extraordinary feat even for a spacecraft equipped with advanced instrumentation. Yet 3i Atlas, an allegedly inert interstellar rock, is doing exactly that. When plotted side by side, the waveforms look like a duet. The sun pulses, the object echoes, not instantaneously, but with a consistent delay of 43.2 seconds. Always the same delay, always the same phase response. In natural systems, delays drift. They stretch, shorten, or vanish as magnetic conditions evolve. But this one remains locked, as if time-coded. Some scientists have attempted to describe the phenomenon as a harmonic resonance, a magnetic feedback loop created by the interaction between the object's metallic composition and the solar field. But those models fall apart when you account for distance. 3i Atlas is currently more than 130 million kilometers from the Sun. No passive magnetic coupling could sustain that kind of precision over such a gap. That's why the word lock is so apt. The object isn't just resonating, it's tracking. To visualize it, imagine a radio tuning itself. The Sun emits a chaotic band of frequencies, but 3i Atlas seems to have found one narrow channel and locked onto it, adjusting its emissions to stay aligned. When solar activity rises, the object compensates, matching phase. When it drops, it compensates again. The correlation coefficient between the two waveforms exceeds 0.98, far beyond any coincidence. In practical terms, it's as if the object has synchronized with the Sun. Not gravitationally, not thermally, but electromagnetically. The implications are staggering. If this synchronization is deliberate, it means 3i Atlas has an active feedback mechanism capable of sensing magnetic flux, interpreting it, and responding in structured intervals. That's not a rock, that's a system. And if it's natural, then we've discovered a magnetic interaction completely unknown to science. One that could reshape our understanding of how conductive interstellar materials behave near stars. Either way, it's a discovery no one seems eager to announce. Inside NASA, references to the frequency lock have all but vanished from internal summaries. The few documents that do mention it use vague terms like synchronous field perturbations. ESA's internal database lists it as a telemetry phase anomaly. The deliberate ambiguity feels strategic, a way to discuss the phenomenon without acknowledging its precision. But independent scientists are not staying silent. Dr. Pavel Rachkov, a plasma physicist from the University of Warsaw, presented a preprint on October 19th outlining what he calls active magnetic feedback between 3I Atlas and the heliospheric field. His analysis notes that each magnetic reinforcement corresponds not just to light flares, but to subtle shifts in the object's orbital velocity, micro-corrections less than 0.001 meters per second, synchronized with the magnetic pulses. That is propulsion in all but name. The study stops short of calling it artificial, but the conclusion is clear. The object interacts with the solar field as if it's part of a circuit, drawing, storing, and releasing energy in timed cycles. Rachkov's findings also show something even more curious. The phase delay of 43.2 seconds aligns perfectly with the propagation time of electromagnetic waves travelling from the sun's surface to the object's current position, factoring in plasma drag. That means 3I Atlas is not anticipating the signal. It's reacting to it in real time, exactly as a receiver would. A receiver, or something designed to mimic one. Some analysts now suspect that what we're witnessing is a form of solar synchronization, a process where the object calibrates its energy output to the sun's electromagnetic activity. This could serve multiple purposes: energy harvesting, communication, or perhaps stabilization against solar pressure. The pattern's complexity deepens with every new dataset. When the signal is decomposed into harmonics, it reveals structure. Subbands at exact integer multiples of 8.3 kHz, forming a harmonic ladder up to 66.4 kHz. Natural magnetic fluctuations don't organize themselves that way. In engineering, this pattern is known as harmonic stacking, a method used in signal modulation to increase data capacity while minimizing energy loss. It's a communication signature. No one is claiming that outright, but between closed circles of physicists, the phrase structured modulation is becoming difficult to avoid. Even more unsettling is how the phenomenon evolves. The amplitude of the harmonics is rising. Each day the signal becomes slightly stronger, as if the object is refining its synchronization, tightening its lock on the sun's magnetic rhythm. The alignment curve that was once fuzzy now looks engineered, razor straight and mathematically perfect. The result is a dynamic resonance that has begun affecting the surrounding plasma itself. Instruments aboard the Parker probe show subtle turbulence around the signal frequency, a local disturbance in solar wind density. The plasma is literally vibrating in sync with the pattern, forming a narrow conduit of resonance between the Sun and 3I Atlas. Some are calling it a magnetic bridge. If verified, this would mean energy, real, measurable electromagnetic energy, is transferring along that link. In other words, 3I Atlas isn't just listening, it may be drawing power. The idea sounds impossible, yet the data aligns. As the frequency lock strengthens, the object's thermal output increases slightly, its nickel emissions rise, and its rotation remains perfectly stable, as though it's feeding on the sun's rhythm and converting that resonance into mechanical control. And here's where the story takes a darker turn. On October 24th, during a period of increased solar activity, the signal briefly shifted. The main frequency jumped from 8.3 to 8.5 kHz. A small change, but one that broke its perfect alignment. The effect was immediate. The flare pattern paused, then resumed at the new frequency exactly 43.2 seconds later. It adapted. That single adjustment shattered any illusion of coincidence. Nothing passive could react to a solar frequency change with that precision. It was an action, a deliberate correction to maintain synchronization. In engineering terms, it's called frequency tracking. The ability of a system to follow an input signal automatically, and it's only found in devices designed to do so. At that point, speculation inside the scientific community erupted. A few suggested that 3I Atlas might be acting as a natural plasma resonator, amplifying solar magnetic fields. Others quietly admitted the unthinkable, that it could be an artifact, a construct built to communicate or draw power from stars. The distinction no longer matters as much as the fact. Something is locking onto the sun. And in just 4 days, that something will pass behind it, invisible to every instrument we have. If the resonance continues during conjunction, the sun itself will shield the interaction from direct observation. For weeks, we'll have no data, no eyes, and no way to know what happens. The last telemetry before the blackout will capture the moment the frequency lock peaks. Analysts are already calling it the handover point, the instant when 3I Atlas becomes fully synchronized with solar oscillation. After that, we wait. Whatever this object is, it's no longer just reacting to the sun. It's part of it, tuned to its pulse, bound to its frequency, locked in perfect harmony with its power. And the question that now haunts every researcher tracking its signal is this: when it comes back into view, will it still be where physics says it should be? As 3I Atlas edges closer to superior conjunction, the thermal, magnetic, and gravitational stresses acting upon it are immense. The combination of solar heating, rotational torque, and tidal differentials from the sun should have fractured its surface long ago. For any cometary body, even a dense metallic one, the limit of structural cohesion under these conditions would already have been exceeded. Yet observations from early October through today, October 25th, show no fragmentation, no shedding, no signs of rotational instability. It's not merely intact, it's stable to the point of defiance. To understand the anomaly, one must look at what has happened in the last 10 days. Spectroscopic imaging from the VLT, Very Large Telescope, and follow-up analysis by the IRTF array confirmed a nearly perfect continuity of the object's albedo features. No new brightening events, no dust clouds, no debris tails. In standard cometary evolution, perihelion approach produces violent shedding. Temperatures spike, jets burst unpredictably, and fragments scatter. 3I Atlas has done none of that. The infrared profile remains crisp, as if its outer layer resists sublimation altogether. The last time an object behaved even remotely like this was in 2006, when Comet 73P/Schwassmann-Wachmann 3 split under much gentler stress. That event involved a smaller body with a fraction of the heat input. 3I Atlas, subjected to at least 4 times the energy flux, remains a singular mass. The numbers make no sense. Using the current energy balance, thermal expansion should induce internal stress exceeding 15 kilopascals. That's enough to fracture a rocky core or cause microcracks in metallic matrices. Yet radar returns from the Deep Space Network show no change in its radar cross-section, meaning the surface hasn't deformed. Even the spin period, measured at 2.07 hours, hasn't shifted beyond plus or minus 0.01% since tracking began. Something inside the object is compensating, either absorbing or distributing stress in a way no inert body could. NASA's Materials Division tried to model this by hypothesizing a composite structure, a layered shell of nickel interspersed with voids or magnetic domains that flex under heat. But even that would eventually fatigue. Unless the material isn't merely strong, it's adaptive. Somewhere within the classified archives of material science, there's a term for such substances: self-healing alloys. On Earth, they exist only in laboratories, metals that rebind molecular bonds when fractured under current or heat. They require energy input, control systems, and deliberate engineering, and that's precisely the behavior 3I Atlas displays. During flare cycles, its surface temperature spikes sharply, then returns to baseline within seconds. Each spike coincides with a measurable change in reflectivity, a subtle darkening, as though the surface briefly liquefies or reorders. The effect is faint but repeatable. To those studying the data, it looks eerily like annealing, the industrial process of heating and cooling metals to relieve stress and restore structural integrity. If that's what's happening, it means the object is literally repairing itself as it travels, converting solar heat into mechanical resilience. The implications are staggering. An interstellar body capable of thermal self-regulation and structural self-healing would represent a class of material science centuries ahead of current technology. It would also explain why its surface composition appears so uniform, a self-maintaining skin that smooths over imperfections automatically. This theory gained unexpected support from radar polarimetry. Normally, radar signals scatter unevenly off rough or fragmented surfaces, but when the Deep Space Network beamed a signal at 3I Atlas earlier this month, the echo returned clean. The depolarization ratio was almost zero, implying an astonishingly smooth and possibly conductive exterior. Even the most polished asteroids exhibit irregular scattering. This one behaves like a machined surface. ESA analysts, in an unpublicized report, called it specular reflection, indicative of metallic continuity, a phrase that, in plainer terms, means polished metal. That same report included an overlooked detail. The radar return time varied by microseconds in sync with the flare cycle. In other words, the object's reflectivity shifts rhythmically, almost as if the outer layer expands and contracts in tandem with its energy pulses. If the object were alive, one might call that breathing, but there's something even more unnerving. Using faint echoes captured by the MRO before the disk blackout, analysts reconstructed a partial surface map, a silhouette broken by geometric ridges. Unlike natural craters or fissures, these features show right angles. The pattern repeats in radial symmetry, 12 sections around the circumference. Such regularity is not geological, it's structural, and it suggests assembly. Skeptics argue that light angles or resolution limits could produce illusions of geometry, but the pattern persists across instruments. Even when viewed at different phase angles, the same ridge distribution appears, 12 radial segments, each exactly 30 degrees apart. If this were coincidence, it would be the most precise one in astrophysical history. So what holds it together? What resists the tidal shear of a star and the mechanical fatigue of interstellar travel? One proposal, circulating among classified research circles, describes a field-bonded lattice, an internal magnetic structure that uses induced current to maintain cohesion. Essentially an object bound not by chemical bonds but by magnetic architecture. The stronger the surrounding field, the tighter its structure becomes. That could explain why 3I Atlas grows more stable as it approaches the Sun. It's literally feeding on the star's magnetic strength. In that sense, the solar environment doesn't threaten it, it sustains it. This hypothesis aligns disturbingly well with the observed frequency lock described in the last chapter. The magnetic resonance may not just power it, it may hold it together. The Sun becomes both energy source and structural anchor, an interstellar umbilical, invisible yet vital. If true, the implications are enormous. It would mean that 3I Atlas's approach toward the Sun isn't reckless, it's intentional, a calculated move to recharge or realign its internal framework. The sun-pointing jet, the harmonic synchronization, the constant temperature, all parts of a self-sustaining system designed to operate within a stellar field. In private, some engineers at ESA have begun referring to it as a magnetostructural vehicle, though the term never appears in public documentation. NASA's official stance remains cautious. The most recent press note on the object refers to it blandly as a thermally resilient interstellar body. But the data speaks differently. A body cannot resist disintegration at 500 degrees Celsius for weeks while maintaining rotational stability, chemical uniformity and geometric precision, not without purpose. That's why several independent researchers have begun publishing under pseudonyms, releasing analyses to underground data repositories. Their models predict that the object's internal stress cycles are not random but phased, modulating in patterns consistent with active load management. It's not enduring the sun's heat, it's using it to flex. Flexibility as defense, elasticity as design. Even the tail, or lack thereof, reinforces this narrative. Instead of the diffuse, chaotic plume expected from sublimation, the venting remains concentrated and directional. That controlled emission likely helps regulate angular momentum, serving as both cooling mechanism and stabilization jet. Every measurable property, light, heat, magnetism, geometry, points to a unified design language, resilience through regulation. Yet within the agencies, the tone is nervous. Engineers understand structures, and they know what they're looking at. The data implies comprehension, a response to environment, not mere resistance. If that's true, the object's behavior near the Sun will be critical. Superior conjunction will expose it to magnetic turbulence that could tear apart ordinary metal. If it endures unscathed, it means its structural stability is not a coincidence. It's intentional, and that would force a redefinition, not just of what 3I Atlas is, but of what's possible. Because in space, nothing endures like this unless it's meant to. In 4 days, as it passes behind the Sun, we will lose sight of it. If it emerges intact, it will have survived conditions no natural body can. And if it doesn't emerge where it should, it will mean something else entirely. That its resilience wasn't for survival, but for maneuver. Because structures this precise are rarely built to last. They're built to move. For weeks, NASA's public communication about 3I Atlas has been strangely muted. Routine briefings, deflections, and stock phrases like, "under further analysis." But behind closed doors, the tone has changed completely. Leaked meeting notes, internal emails, and cross-agency chatter paint a portrait of quiet panic, an organisation paralysed between data and disclosure. The first signs of tension surfaced in early October when the Jet Propulsion Laboratories astrodynamics team circulated a classified summary labelled Trajectory Deviation Review. The report didn't announce any discovery, it asked a question. If 3i Atlas exhibits self-correcting orbital behaviour, how do we quantify control? That word, to control, triggered a cascade of internal policy discussions. According to sources within the Planetary Defence Coordination Office, several administrators wanted to release an interim statement acknowledging the unusual regularity of the object's trajectory, but the Office of Communications vetoed it within hours. The reason given: insufficient contextual framework for public interpretation. In simpler terms, we can't explain this without starting a firestorm. There is precedent for such restraint. During the early months of the Oumuamua observations in 2017, NASA followed a similar pattern: slow releases, vague language, and a final report that quietly minimised anomalies. The lesson was clear: uncertainty feeds hysteria. Better to say less than to admit you don't know. But 3i Atlas is not Oumuamua. It's brighter, closer, and behaving in ways that defy every category the agency has for interstellar objects. And this time, the silence itself has become the story. Within NASA's scientific divisions, the debate isn't about what's happening, it's about what to call it. The plasma physics branch insists on describing the frequency lock as a magneto-hydrodynamic coupling event. The thermal division prefers nonlinear surface response. The Astrodynamics Office, perhaps the most candid, labels it anomalous attitude stability. Each description deliberately avoids the implication of intent. Yet as the evidence mounts, the technical language begins to sound like denial. In an internal memo dated October 18th, a senior mission analyst wrote, "We're encountering data that cannot be reconciled with cometry or asteroidal physics. If we persist in reclassifying anomalies instead of acknowledging them, we risk credibility collapse." That line, credibility collapse, has since circulated widely within NASA, though few dare repeat it outside internal channels. Because the dilemma isn't scientific, it's existential. If the agency publicly entertains the idea that 3i Atlas might not be a natural object, every other space mission becomes suspect. Every unexplained signal, every atmospheric flare, every anomaly, all of it reopens under a new lens. The precedent would be irreversible. And then there's the geopolitical side. The moment an object is described as potentially artificial, it stops belonging to science and enters the realm of national security. The Pentagon, through the US Space Command, has already requested telemetry access. Officially, the purpose is to monitor orbital perturbations. Unofficially, it's to determine whether the object's behaviour constitutes manoeuvring. If 3i Atlas moves even a fraction of a degree off its predicted post-conjunction trajectory, military involvement becomes automatic. The US, the European Union, and even China have contingency protocols for extraterrestrial artifacts of unknown function. The first step is information lockdown. The second is jurisdictional transfer from scientific to defence oversight, which explains NASA's silence. The agency's leadership knows that transparency will trigger immediate escalation. By maintaining a facade of scientific ambiguity, they buy time. Time to analyse, to verify, and perhaps to prepare. Inside the Jet Propulsion Laboratory, scientists are divided into two camps. The first, cautious, procedural, believes the anomalies will eventually yield to natural explanation. The second, smaller, quieter, is convinced the data already exceeds those limits. One physicist, speaking off the record, put it bluntly, "We're watching something act like it understands the sun better than we do." That statement captures the atmosphere within the building, or wrapped in dread. According to an internal schedule leaked from the Deep Space Network's tracking division, NASA has been running dark simulations, predictive models assuming active control from within 3i Atlas. These simulations test how small, continuous micro-thrusts could produce the observed orbital perfection. The results are classified, but one line from the model summary slipped through. Observed trajectory matches active correction parameters with intolerance plus or minus 0.0005. In other words, the data fits a controlled object better than it fits a drifting one. At that point, the conversation stopped being scientific. It became political. The next question was obvious. If this is an artifact, who built it, and what does it want? No one dares address that publicly. NASA cannot speculate without evidence, and evidence requires proof beyond telemetry. Proof would mean direct observation, radar imaging, spectroscopy, or a close pass from a probe. None of those are possible before conjunction, so the agency waits. Privately, so does everyone else. The European Space Agency's internal communications mirror NASA's hesitation. A leaked email from a project coordinator in Darmstadt reads, "Public narrative stability remains the priority. Interpretive risk outweighs scientific urgency." That sentence may be the most honest of all. The fear isn't what the data shows, it's what the story might become once people start connecting the dots themselves. Meanwhile, smaller observatories, amateur and academic, are doing exactly that. Independent researchers continue to publish unfiltered analyses online. Their graphs, plots and spectra are messy but genuine, and almost all of them point to the same conclusion. 3i Atlas is doing something deliberate. NASA's own analysts know these papers exist. They read them. Some even contribute anonymously. But institutionally, the agency remains frozen between two incompatible truths: the scientific truth that data should be open, and the bureaucratic truth that some discoveries are too destabilizing to announce in real time. It's a collision between knowledge and control. The irony is that the agency was built for moments like this. Moments when the unknown demanded courage. But now, the unknown demands caution. The closer 3i Atlas approaches the Sun, the greater the pressure not to make a mistake that history won't forgive. If they reveal too much and it turns out natural, they'll be mocked for hysteria. If they reveal too little and it turns out not natural, they'll be remembered for silence. Either choice fractures trust, and so they choose a third path: delay. They let time make the decision for them. In 4 days, 3i Atlas will pass behind the Sun. When it re-emerges, its path will tell the truth, one way or another. If it stays the same, NASA will breathe again. The world will move on. If it doesn't, if it shifts even slightly, the world will never be the same. For now, the official position remains unchanged. No evidence suggests artificial origin. But inside those walls, even the most loyal scientists know what that phrase really means. It doesn't mean no evidence, it means no admission. Because admitting the possibility changes everything: science, religion, politics, the meaning of being human under a shared sky. And that's the dilemma NASA faces tonight. Tell the truth too early, or hide it too long. Neither choice ends well. October 29th, that's the date circled on every agency calendar, every mission log, and every astronomer's watch list. It marks the beginning of what's known as superior conjunction, when the object passes directly behind the Sun relative to Earth. For approximately 4 weeks, from late October through late November, 3i Atlas will be hidden within the solar glare, invisible to telescopes, radio arrays, and even the Parker Solar Probe's line of sight. This blackout, or as some analysts call it, the blind window, isn't just an observational inconvenience, it's a complete sensory loss. For 27 to 30 days, humanity will have no direct information about what the object is doing. No light curves, no thermal readings, no magnetic data. A total silence between the Sun and Earth, precisely when 3i Atlas approaches its most volatile phase. Under normal circumstances, a conjunction like this would be routine. Spacecraft behind the Sun are often lost to signal interference, and comets disappear from observation all the time. But this time, it's different. Because the disappearance of 3i Atlas isn't just about geometry, it's about timing. Everything strange about this object, the rhythmic flares, the nickel venting, the frequency lock, the orbital precision, is reaching a crescendo right before the window opens, as though the entire sequence of anomalies has been leading to this moment. The resonance frequency between the object and the Sun has now stabilized at 8.5 kHz, with harmonics extending up to 68 kHz. The amplitude curve is flattening, not weakening but plateauing, like a system that has finished calibrating. To many observers, it feels like the prelude to a transition, as if 3i Atlas has achieved full synchronization and is preparing for whatever comes next. That's why the timing of this blackout feels deliberate, because just as the object reaches the height of its anomalous behavior, the Sun conveniently moves between it and us, cutting off every signal path. If that were coincidence, it would be the most unsettling one in astrophysical history. NASA's public statements are predictable. They emphasize the difficulty of observation during conjunction and assure that monitoring will resume, when solar interference decreases, but inside the agency the tone is far less calm. Internal status memos from the Deep Space Network refer to the conjunction as the data gap. One line stands out: critical unknowns during gap, potential change of trajectory not observable until December 1st window. In simpler words, if 3i Atlas moves, we won't know until it's already moved. This blackout poses both scientific and psychological challenges. For those tracking the object daily, the idea of losing it, even temporarily, feels like watching the curtain fall before the final act. Observatories around the world are scrambling for any workaround. Ground-based radio arrays in South Africa, Chile and Japan are preparing to listen for indirect echoes, reflections of solar radio waves that might hint at continued activity. But the odds of success are minimal. The sun is simply too loud. A few engineers at the Parker Solar Probe have proposed a desperate solution: to use the spacecraft's dust analyzer as an improvised detector, searching for charged particle flux anomalies that might indicate continuing flaring. But even if such data are captured, interpreting them would be guesswork. This level of uncertainty is rare in modern astronomy. We're used to seeing everything, recording everything. Now the world is forced to wait in silence, and that silence is heavy, especially because of what might happen during it. 3 possible outcomes dominate every closed-door discussion. Fragmentation. The object could finally break apart under thermal stress. This would end the mystery abruptly. A disintegration event would scatter debris, and when it re-emerges it would appear as a diffuse cloud. Natural, explained, contained. Structural persistence. It could survive intact, proving its resilience but not necessarily its control. Still mysterious but not unprecedented. A durable interstellar relic, enduring the sun's violence. Trajectory shift. The third outcome is the one everyone fears and anticipates. If 3e Atlas emerges from conjunction off course by even a fraction of a degree, it means it moved while unobservable. That would confirm active propulsion, active guidance, active intent. The first 2 outcomes would keep the narrative manageable. The third would change everything. To grasp the stakes, consider this. A deviation of just 0.05 degrees, roughly 1/10 the apparent width of the Moon, would translate to millions of kilometers of displacement by the time it passes Mars's orbit again. That's not drift. That's navigation. And there's a chilling corollary. If 3i Atlas can navigate, it can choose where to go next. NASA's trajectory analysts are running silent simulations under codename Operation Vector. The goal? Predict every possible re-emergence path based on varying thrust levels. Most paths return it to its natural course, but a handful diverge, trajectories that could bring the object within gravitational reach of Earth's orbital plane by late 2026. No one's saying it will happen, but no one's ruling it out either. Meanwhile, mission control teams have been instructed to maintain continuous telemetry capture on the solar side, in case any unexplained electromagnetic bursts occur during the blackout. Essentially, the plan is to listen for signs of movement through the sun's radio noise. The sun will drown most signals, but not all. Low-frequency magnetic pulses, the kind associated with the frequency lock, might bleed through. If 3i Atlas continues transmitting during conjunction, those pulses will appear faintly modulated against the solar background. Analysts are calling this hypothetical detection the Atlas Whisper. And if the whisper is real, if it continues to pulse even when hidden, it would mean the object's resonance with the sun isn't dependent on our observation at all. It would mean the link is self-sustaining. That prospect unsettles even the skeptics. For now, though, we wait. The blind window looms like an event horizon, a gap in knowledge no one can fill until the world on the other side comes back into view. In public, scientists frame it as a simple pause in observation. In private, many admit it feels like a countdown, not to disappearance, but to revelation. Because when 3i Atlas re-emerges, one of 2 truths will be clear. Either it's just another interstellar wanderer misunderstood by human imagination, or it's something far older, far quieter, and far more deliberate, something that uses the sun itself as cover. Until then, the instruments fall silent, the screens go dark, the numbers freeze, and somewhere behind that blinding star, an object we can't explain continues its perfect rhythm, unseen but not gone. October 25th, 4 days until 3, I-Atlas slips into the shadow of conjunction, the perfect blind spot where every telescope, probe and array will fall silent. Inside every observatory and control room, the question has become painfully binary. When it comes back into view, what will it look like? Or worse, will it come back at all? At this point, every scientist, analyst and data modeler involved with the object has the same 3 possibilities written on their boards, printed on their walls or buried in their notes. They call them the outcomes: fragmentation, persistence or change. 3 fates, 3 explanations, 3 paths toward truth, or something that only looks like it. The simplest, cleanest and most comfortable outcome. If 3I Atlas is natural, a comet, a metallic body, an exotic interstellar relic, it should not survive this close pass intact. The solar flux, the tidal strain, the heating and torque at its current distance will exceed anything an unreinforced object could endure. To put that in perspective, at its current perihelion approach, the incident energy from the Sun exceeds 1,800 watts per square metre. Its surface temperature, already at nearly 490 degrees Celsius, is projected to spike past 600 degrees Celsius before the end of conjunction. Even nickel begins to weaken at that point, losing its structural rigidity. A natural object would fracture, vent, collapse into vapour and dust. Fragmentation would end the mystery immediately. When it re-emerges in late November, it would appear as a broad cloud of dispersed metallic debris, glowing faintly, spinning chaotically, beautiful but ordinary. NASA would call it a thermal disintegration event. The Akarunia model would be vindicated, and the world would quietly exhale, grateful that the strange rhythm, the flares, the harmonics were all just prelude to collapse. In this outcome, 3I Atlas dies the way comets do, violently, naturally, predictably. But very few at NASA still believe that will happen. The object's behaviour in the last month has already broken too many rules. Its stability under stress, its refusal to spin out, its perfect structural resonance, all point to endurance, not decay. If it were going to fragment, it likely would have done so weeks ago, when the flares first intensified. That leaves 2 other outcomes. The second scenario, endurance without change. If 3A Atlas emerges exactly where it should be, moving along its predicted orbit, intact but unaltered, then the mystery deepens but remains containable. It would prove that the object's resilience is extraordinary but not necessarily intelligent. NASA could frame it as material anomaly. ESA could cite unknown metallurgical composition. The public would marvel for a few days, then move on. But scientifically, it would be revolutionary. It would mean that nature, somewhere out there, can produce self-regulating, heat-resistant, magnetically coherent bodies, a kind of interstellar metal that behaves like technology but isn't. The implications for cosmochemistry would be enormous. New models for metal-rich condensation, for plasma coupling, for heat balance in deep space. A natural explanation, miraculous but still natural, would preserve the boundaries of science, and perhaps that's why so many hope for it, because the third outcome, the one everyone whispers about but no one dares predict, would rewrite those boundaries entirely. The scenario that changes everything. If 3I Atlas emerges from behind the Sun displaced even slightly from its projected position, it means one thing. It maneuvered. Not drifted, maneuvered. Space is unforgivingly precise. At interplanetary distances, motion obeys gravity, pressure and momentum, all governed by equations that leave no room for surprise. If the object's path deviates by as little as 0.05 degrees, that deviation cannot come from chance. It would require active correction, energy input, thrust, control. And if 3I Atlas controlled its trajectory, the debate about natural versus artificial origin ends instantly. It becomes the first verified non-terrestrial object operating under apparent guidance. That possibility is the reason NASA has gone silent. It's why the European Space Agency has quietly shifted all 3I Atlas coordination under its classified Space Situational Awareness Division. It's why data uploads to public repositories froze on October 18th, because a trajectory shift doesn't just mean motion, it means intention. The scale of that revelation is almost unthinkable. Entire fields, astrophysics, cosmology, theology, would have to absorb the idea that something else in this galaxy is active, aware, and capable of engineering on scales beyond human comprehension. Even the smallest maneuver, a slow rotation, a corrected drift, would be historic. And yet, some within NASA fear a fourth possibility, one no one wants to put in writing, that it might not just change course, but disappear, not fragment, not drift, not persist, simply vanish from detection. If that happens, the implications are even stranger. A disappearance could mean deflection, rapid acceleration, or the activation of some kind of shielding mechanism. Anything that renders it invisible to the instruments we rely on. Such an event would devastate public confidence in observational science. But for many inside the agency, it's the only remaining explanation for an object that has behaved as if it understands how to hide. While the public waits, the internal modelling continues. At JPL, teams are running thousands of simulations every night. Most predict persistence, a few predict fragmentation, but every now and then, one simulation, just one out of thousands, returns an impossible result, a stable orbit that abruptly alters velocity during conjunction, as if an impulse occurred from within. Each time that result appears, the simulation is flagged as non-physical. The system resets, and the model starts again. But the pattern keeps returning, buried deep in the probabilistic noise, refusing to vanish. No one knows what to make of it. For now, NASA's official communications maintain composure. The press releases are brief, the language antiseptic, observational challenges due to solar interference. Further data analysis forthcoming, but inside those words is a silence that says more than any statement could, because every engineer, every physicist, every data analyst watching the telemetry fade into solar noise knows exactly what this moment means. We're standing at the edge of the unknown, a moment when the next data packet could redefine what humanity knows about life, creation, and control. If it breaks apart, we breathe again. If it survives, we marvel. If it moves, we begin a new chapter in history. And all the while, an unspoken truth lingers in the background. For an object travelling millions of kilometres through deep space, hiding behind the brightest star in the sky, 4 weeks of invisibility is an eternity. A lot can happen in eternity. Because behind that curtain of light, where no human eye can see, something may already be unfolding, silently, precisely, purposefully. The countdown continues. By now, the data from 3i Atlas reads like a riddle written in waves. Nickel vapour outgassing in measured intervals, magnetic harmonics locked to the sun, thermal pulses that rise and fall in time with solar oscillations. Each of these could, on its own, be dismissed as coincidence, but together they form a pattern that feels deliberate. The scientists tracking it are trained to doubt their instincts, to treat the appearance of order as a trap. Nature loves to imitate design. But what's unfolding in the telemetry of 3i Atlas doesn't imitate. It persists, it adapts. An adaptation, in the vacuum of space, is not a trick of geometry. It's an act of feedback. When the Parker Solar Probe last recorded the object's electromagnetic profile before the signal blackout, analysts noticed something new, a low-frequency subharmonic oscillation buried beneath the 8.5 kHz main resonance at exactly 1.42 GHz, the same frequency that hydrogen atoms emit naturally when their spins align and flip. That number, 1.42 GHz, is not random. It's known in astronomy as the hydrogen line, the universal constant of the cosmos, used by scientists as a reference for interstellar communication. The frequency is so iconic that in 1974 humanity used it to transmit the Arecibo message, our first deliberate radio signal to potential extraterrestrial life. Now, something out there seems to be echoing it. When the hydrogen line was first detected within the object's magnetic envelope, the response from NASA's Deep Space Network was immediate. Double-check the instruments. Hydrogen frequencies are common, especially near solar plasma. But the timing, coinciding precisely with the object's final pre-conjunction flare, sent quiet shockwaves through the analysis teams. At first the signal was dismissed as reflection, perhaps sunlight scattering off ionized gas. But then came the modulation. Superimposed on the 1.42 GHz carrier was a faint repeating pulse, a binary-like sequence, not continuous, not random. Bursts of 3, pauses, then bursts of 5, over and over, 3 to 5. It lasted less than 2 minutes before fading back into the solar background. But in that short window, the entire tone of the investigation changed. Inside JPL, the data was classified immediately under internal code Atlas 14. Only a handful of people have seen the unfiltered waveform, yet fragments leaked through an independent analysis group at the University of Cambridge, which confirmed that the modulation is real. To put it simply, the signal shows structure. It's not speech, it's not language, but it's order, measurable, repeatable, deliberate order. Of course, skepticism remains fierce. The prevailing counter-argument is that this so-called hydrogen line pulse is nothing more than plasma resonance. When highly metallic particles, like those vented by 3i Atlas, interact with the solar wind, they can create standing waves in the local magnetic field. These waves could, theoretically, align with hydrogen's emission frequency by accident. It's a solid hypothesis, on paper, but it doesn't explain why the sequence would appear in multiples of 3 and 5, nor why the pulses show uniform phase spacing, with nanosecond precision. Random plasma noise doesn't repeat in perfect intervals. Dr. Nina Lorenz, a physicist at the Max Planck Institute, phrased it carefully in a private briefing. If this were random, the pattern would decay. It's not decaying, it's maintaining coherence. Still, she stops short of calling it communication. We may be witnessing a feedback loop between the object's magnetic structure and the solar flux, she adds. That feedback could naturally quantize into regular bursts. In other words, the sun might be teaching it to sing, without anyone meaning to. It's a beautiful idea, a cosmic duet, unintentional but harmonious. Yet others believe the precision goes beyond harmony. The deeper analysts look into the historical data, the stranger it gets. Using archived readings from earlier in the object's approach, researchers have identified smaller echoes of the same binary-like pulse, hidden in background noise dating back to September 9th. The frequency was weaker then, almost lost in static, but the 3 to 5 structure was already forming. That means the modulation wasn't a sudden event. It's been building, strengthening, refining itself as 3i Atlas drew closer to the sun. Even more intriguing, the pulse intervals align perfectly with the object's rotation period and flare cadence. In essence, every physical movement of 3i Atlas, every vent, every pulse, every flare, mirrors the timing structure of that signal. It's as if all these separate anomalies are parts of one synchronized system, mechanical, magnetic, or something in between. To many observers, this looks like calibration, and calibration implies purpose. The sequence, 3 bursts, pause, 5 bursts, has become a quiet obsession among researchers. Some see mathematical simplicity, 3 and 5, the 3rd and 5th primes. Others point to their sum, 8, the same integer ratio at which the harmonic frequencies of 3i Atlas stabilize relative to the sun's magnetic resonance, 8.5 kHz. In music theory, 3 and 5 form a major chord, a harmonic consonance. In physics, they represent one of the simplest stable ratios of oscillation. Whether coincidence or code, the pairing is elegant. One analyst described it poetically. If you wanted to announce your presence to a civilization that understands mathematics, you'd start with primes. But if you wanted to announce your intelligence to the universe itself, you'd use harmony. NASA and ESA have reacted differently. NASA's internal communications refer to the pulse pattern as a temporary interference event. ESA's Darmstadt Operations Center calls it a structured anomaly requiring further classification. In practice, both mean the same thing. No one is willing to label it what it looks like. That hesitation is strategic. If the agencies acknowledged that the signal has structure, they would have to classify it under SETI protocols, the same procedures used for detecting intelligent transmissions. Doing so would make the data public by law, so they don't. They sidestep the language entirely. Meanwhile, SETI itself has been monitoring the solar background, searching for independent confirmation. So far, nothing. The 3 to 5 sequence hasn't appeared in any other direction. It's localized, bound to the path of 3i Atlas. This geographical isolation eliminates the chance of an Earth-based reflection or a satellite glitch. Whatever the pulse is, it's coming from out there. At this point, the scientific debate is less about the data and more about philosophy. How much order must appear before coincidence stops being plausible? If 3i Atlas was simply reacting to the sun's energy, we might call it a passive phenomenon. But the structure of its emissions, consistent, rhythmic, adaptive, resembles agency. Not necessarily intelligence in a human sense, but something with internal coherence. It could be automated, ancient, or purely physical in ways we don't yet comprehend. But it is not chaos. Every observable property of this object, its orbital precision, its heat regulation, its material resilience, its resonance with the Sun, converges toward one conclusion. 3i Atlas behaves like a system, a functioning system, and systems serve purposes. Whether the pulse is a message, a control signal, or a natural harmonic, we may never know. But what we do know is that it's unique. No other interstellar object, comet, or asteroid has ever displayed this level of organized activity. The last confirmed detection of the 3 to 5 pulse came at 0417 UTC, October 25th, today. After that, the signal faded into the solar background. Some interpret that as cessation. Others suspect it's simply being absorbed by the Sun's electromagnetic field as the object moves into conjunction. A few analysts believe something else entirely, that the signal didn't end. It completed. That its pattern, 3 bursts, pause, 5 bursts, wasn't a repetition but a countdown. 3, pause, 5. A simple sequence, closing on 8. The same harmonic ratio that defines its lock with the Sun. If that's true, it means the final transmission wasn't noise. It was a synchronization marker, a handoff. The moment the object aligned fully with the solar field and ceased broadcasting because it no longer needed to. If so, then somewhere behind that blinding star, 3i Atlas is no longer signaling to the Sun. It's now part of it, connected, and the next time we see it, if we see it, the question will no longer be whether it's communicating. It will be whether it ever stopped. October the 25th, the threshold of silence. The countdown to conjunction has begun, and the hum of activity inside every observatory has slowed into a strange collective quiet. Data streams that once pulsed every minute now taper off. Instruments are being recalibrated for the long wait, and somewhere beyond that blinding curtain of plasma, 3i Atlas continues its rhythm, unseen, unmeasured, and possibly no longer alone in its own motion. This is the last stretch before the moment of truth. In science, silence is rarely dramatic, but this one feels different. The agencies aren't calling it that, of course. Officially, it's the observation gap. Yet every researcher knows what's at stake. When 3i Atlas emerges again from behind the Sun in late November, the data will do what speculation cannot: decide the narrative. If it returns fragmented, we close the book. If it remains stable, the mystery deepens. If it shifts course, even slightly, the story changes forever. At the Deep Space Network in Goldston, California, they're already preparing for that reappearance window. Arrays are being retuned to frequencies far lower than usual, not to see the object, but to listen for it. Any echo, any modulation in the returning solar wind could serve as a sign that the object survived the inferno. Because by now, survival itself would be remarkable. 3i Atlas has endured heat levels that would vaporize iron, magnetic turbulence that would tear apart solid metal, and radiation that would blind most sensors. Yet all projections, temperature, spin, orbit, point to persistence. The question isn't whether it can survive, it's what survival will mean. Inside NASA, there's a palpable sense of containment. The tone of communications has shifted from cautious curiosity to something quieter, more procedural, the language of controlled waiting. No official statements will be issued until new data arrives. That's the rule. No confirmation, no denial. But internally, small teams continue to simulate post-conjunction outcomes under classified headers. The models run endlessly, adjusting thrust assumptions, energy balances, radiation flux. Each time they run a maneuvering model, the results align disturbingly well with what the real object has done so far. According to a leaked internal document titled Event Horizon Contingency Plan, NASA has outlined 3 phases of response following re-emergence. Phase 1, confirmation, immediate triangulation of the object's position via radar and optical lock. Phase 2, assessment, cross-check against pre-conjunction predictions. Any deviation beyond 0.05 degrees triggers Level 3 anomaly status. Phase 3, containment, coordination with US Space Command for trajectory monitoring and possible reclassification under national security review. In simple terms, If 3I Atlas moves, it leaves NASA's hands. That's why so many scientists inside the agency are both terrified and fascinated by what's coming. They know that discovery and secrecy are about to collide, and only one will survive. The 4 days leading to October 29th have become a ritual of anticipation. Observatories across the world hold nightly synchronizations comparing the last visible data. It's a strange kind of vigil, the scientific equivalent of holding a candle under a star that won't stop pulsing. The last clean image, captured on October 24th by the Solar Orbiter's remote imager before transmission blackout, shows 3I Atlas as a tiny green-white point framed by the sun's corona. A faint glow directed forward, not trailing, the same impossible sun-pointing jet. In that final image, the flare intensity curve rises sharply, then flattens into perfect symmetry, a waveform so regular it looks engineered. It's the closest thing to a goodbye signal we'll get before the light swallows it. Scientists have given it a nickname, the closing eye, because after that there will be nothing but the sun's glare. For now, the public remains largely unaware of how much hangs on these next few weeks. Media coverage has quieted, NASA's vague updates have calmed the noise, but online, independent researchers and amateur astronomers are building their own models, and their predictions are more daring. Some suggest that 3I Atlas could re-emerge brighter than ever, reflecting enhanced solar interaction. Others think it will appear dimmer, cloaked in its own field. A few whisper about the possibility that it might not appear at all. Social media forums are filling with speculation. If it's artificial, who sent it? If it's natural, why is it acting like it's alive? If it's signalling, who's listening? For every official silence, 100 new voices rise to fill it. And somewhere within that noise, fragments of truth may already be echoing. The scientists monitoring 3I Atlas aren't afraid of the object itself, they're afraid of what comes after. If it reappears exactly as predicted, they'll face the burden of rewriting physics to explain its endurance. If it moves, they'll face something far harder, rewriting reality. Because a trajectory shift doesn't just prove control, it proves awareness. That awareness doesn't have to mean intelligence in the human sense. It could mean a self-regulating machine, a relic of a civilization long gone, or a natural system so complex it mimics intent. But the distinction won't matter to the public. Once an object demonstrates control, it ceases to be it. It becomes someone, and that changes everything. Policy, theology, even history itself. For NASA, it would be the end of its monopoly on knowledge of the unknown. For humanity, it would mark the first time we'd look into the dark and realise the dark might be looking back. The last ongoing project before the blackout is a coordinated global effort called SIS, the Solar Interference Study. Its goal, to use the sun itself as a carrier medium to detect indirect signs of activity during conjunction. Radio telescopes from Hawaii to South Africa are tuning to the 8.5 kHz base harmonic and the 1.42 GHz hydrogen line, searching for faint modulation, the ghost of that now famous 3 to 5 pulse. If even a fraction of it persists, it will mean the frequency lock remains active behind the sun. That in turn would imply continuity of function and likely intention. But so far no one knows what to expect. The sun's interference could drown every whisper, or it could amplify it, like a magnifying glass focusing light onto an unseen page. Late November, that's when the silence ends. When the object emerges, the first readings will determine which world we wake up in. If the coordinates match, we return to certainty. If they don't, we enter the unknown. There are quiet preparations for both, contingency plans, press drafts, scenario simulations, even psychological briefings for mission staff. Some scientists privately admit they're not ready, not for the truth, whatever it is. Because if 3I Atlas moves, we will have to redefine what alone means. And if it doesn't move, if it emerges unchanged, resilient, perfect, we still have to ask why. Why build something that can survive the sun? Why send it here? This is where the story pauses, not ends, pauses. Because the next chapter won't be written by speculation or by scientists. It will be written by data. In less than a week, 3I Atlas will vanish. Then, for a month, there will be nothing. No signals, no telemetry, no proof. Only the hum of the sun and the quiet tension of waiting minds. When it reappears, there will be no debate left. It will either emerge as what we think it is, a comet, a relic, a machine, or as something we can't yet imagine. Until then, the instruments fall silent. Humanity looks toward the sun, toward the place where light becomes blindness, and somewhere behind that light, an object older than our species and colder than our machines holds its course or chooses another. The next signal we receive will define our place in the universe, because what 3i Atlas does when no one is watching, that is the moment of truth. For months, 3i Atlas has been both an object and a mirror, a fragment of motion reflecting everything humanity doesn't yet understand about itself. Its rhythm, its defiance, its eerie precision have forced us to confront a truth that most of science spends lifetimes avoiding. We are not in control of what we find. We only interpret it. Behind the sun, in a place no instrument can yet see, an object the size of a mountain is moving through plasma dense enough to melt iron, and it's doing so without faltering. Every signal that preceded its disappearance told the same story: regulation, resonance, restraint. It flared, but not chaotically. It synchronized, but not passively. It responded, and now we wait to see what it responds to next. The most unsettling part of this moment isn't the data we've lost, it's the silence itself. Silence used to mean ignorance. Now, it might mean activity. If 3i Atlas is still in perfect rhythm with the sun, then the blackout we're entering isn't the absence of observation, it's the absence of witness. The object will continue doing whatever it was built, programmed, or formed to do. Only we will be blind to it. The idea of being deliberately excluded, of something timing its most crucial phase for the one period when no one can see, has shaken even the most grounded scientists. If it's natural, it's indifferent, one astrophysicist wrote. If it's not, then it knows we're watching. In that single distinction lies the haunting gravity of the event. The world's observatories, once a chorus of instruments, have fallen quiet. The last data packets have been archived, analysed and locked. The debates are over. What remains is a single, enormous unknown. Not about chemistry, magnetism or trajectory, but about behaviour. Because everything about 3i Atlas, from its metallic chemistry to its self-stabilising spin, suggests purpose. The sun-pointing jet could be propulsion. The nickel venting could be regulation. The frequency lock could be communication. Or none of those things. Or all of them. We've reached the edge of what evidence can tell us. The rest is interpretation and waiting. Perhaps that's the real significance of 3i Atlas. Not that it's an interstellar visitor, but that it's a reflection of how humanity confronts the unknown, with curiosity, with fear, with a desperate need to name what we don't yet understand. Every signal we've received from it has forced us to ask a deeper question. Not what is it, but why do we need it to be something familiar? Maybe it isn't artificial. Maybe it's a natural engine of cosmic order, a reminder that the universe still invents mechanisms stranger than our imagination. Or maybe it's exactly what the data implies. An engineered object, precise enough to use a star as both power source and shield. Either way, it has already done what no signal, no spacecraft, and no discovery ever has. It has united science and speculation under one quiet emotion. Or, in the old days, astronomers listened to static and called it the voice of the universe. They knew that most of what we hear in space isn't a sound, but an echo, an imprint of energy, time, and distance layered upon itself. Maybe that's what 3i Atlas is too, an echo from something that came before us, crossing light years to remind us that the laws we thought immutable are only local customs of the cosmos. When the object reappears, whatever it is will not change what it already means. Its story has already reshaped how we think about isolation, probability, and the fragile arrogance of assuming the universe runs on our understanding. The echo has already been heard. The data was never the message. The message was the pattern, the rhythm that refused to stop. So we wait, not for proof, but for confirmation. Not for explanation, but for revelation. And as the sun swallows 3i Atlas from sight, one truth remains suspended in the silence it leaves behind. The universe has never been quiet. We just haven't always been listening in the right frequency. When the light returns and the first signal pierces through the static again, we will know. Not because it tells us what it is, but because it will tell us what we are willing to believe. Until then, Every instrument sleeps, every screen goes dark, and every scientist becomes what they were before the data began, a listener in the dark, waiting for an echo. And somewhere behind that star the object drifts on, steady, silent, synchronized. Perhaps it will return unchanged, perhaps it will not return at all. Either way, the moment of truth has already passed. We heard the echo, and that was enough.